Hey all, so today in this video lesson, we're going to be looking at the graph of a quadratic function and exploring what key features, if you look at that essential question, what are the key features of the graph of a quadratic? So we're going to look at something new today. The first thing we're going to do in this warm-up is just fill in the table for the most basic quadratic function that we can do, which is just f of x equals x squared, or y equals x squared. So first thing I'm going to do is fill out this table. So I've got all these inputs here from -3 to 3. So I'm just going to input those into my function. So I'm going to find like f of -3. That's going to be the same thing as taking -3 squared. Now, the parentheses are really important here because that is saying, I'm actually going to move this over, that is saying that you're taking -3 times itself. So a negative times a negative, that's going to give me positive 9. Oops, that's bad 9. All right, and you're going to do the same thing for all of these. So f of -2 equals -2 squared. -2 times -2 is equal to, nope, that ain't right, 4. So if we plug in -2, I'm going to get out 4. So if you keep going through these, like -1 squared, that's going to give you positive 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. So we have some repeated outputs there, but that's totally fine because remember, a function, the inputs can't repeat. All right, so now that I've got my table filled out, I'm just going to transfer those points over to the graph. So I've got -3, 9. I've got -2, 4. -1, 1. 0, 0. And then we start to repeat the outputs. So we got 1, 1. 2, 4, 3, 9. And we have this, if we were to connect these points now, like in number 1, if we were to connect these points, we have this curve shape here. All right, that it kind of looks like a U a little bit. It should look like a U, not a V. So it's curving down when it hits that low point. All right, so we have a U-shaped curve. Called a parabola. So that might be a new word for you, parabola there, P-A-R-A-B-O-L-A. Parabola is the name of the graph of a quadratic. All right, so like a line is the name of the graph of a linear function. We call the graph of a quadratic a parabola. All right, now notice a couple things here. For number 2, does the graph have a maximum or a minimum? Well, if you look at the graph here, this graph has a minimum. It's got a low point on this graph. Minimum located at, for our most basic function here, y equals x squared, or f of x equals x squared, your minimum is located at the origin, which is just 0, 0. All right, that point there, that minimum value, is called the vertex. That's called my vertex. Okay, so we've got one key feature of our graph, our vertex. So that is called the vertex. Great. That's important information. So that's why I keep repeating it, is because that is a new vocab word that's important to recognize with parabolas. All right, number 3 is asking us to define the domain and range of f. So this is a little bit of review from some previous units. All right, so the domain is all possible inputs there, which is our x values. So if we look at our x values, you got to ask yourself, can I plug in any x value I want? And the answer is yes, because you're just squaring whatever that input is. So we're just going to say all real numbers for the domain, because you can plug in anything you want, positives, negatives, decimals, fractions, anything you want. So all real numbers. But if you remember your range is talking about your outputs or your y's. All right, notice that we do have a restriction on the y's. We're not getting out any values that are negative here because we're squaring. And when we square a negative number, negative times a negative is a positive. So the lowest possible values you can get out is 0, that minimum value at that vertex there. All right, so to describe the range, we would say all reals greater than or equal to zero. All right, 0 is the lowest possible output we can get because that was 0 squared. Now, we're going to see in some later graphs that like sometimes your range is going to change, but it's all going to depend on where that vertex is located and whether that vertex is a maximum or a minimum. All right, domain for your parabolas, the domain, your inputs, will always be all real numbers. Okay, so for the next one, where is f decreasing? So where is this function decreasing and where is it increasing? So if you notice as you look at this parabola, it's going down, it's decreasing first until it reaches your vertex, that minimum value, and then it starts curving back up and starts increasing. So your graph is decreasing when x is less than 0, and f is increasing when x is bigger than 0. Hopefully you can see that on the graph. So I will put, let me see if I can highlight this, decreasing. So it's decreasing here until it reaches the vertex. And then whereas f increasing, it's increasing after it hits that vertex and as it keeps going. Okay? Next one, does f of x have a constant rate of change? How can you tell from the graph? Well, remember, constant rate of change, that's just another word, like this here, this constant rate of change idea, that's just another word for slope. So does this graph have a slope? No, because what function does slope go with? Slope goes with linear. So no, the graph is not linear. Okay, it's steeper. Notice that like as you go through the graph, like we start at 0, then we only go up 1, and then that goes up to 4, and then that goes up to 9. So it's getting steeper in some places compared to others. All right, it is steeper in some places than others. And we saw that too, like with the pattern. When we were talking about quadratic patterns with those dots and those squares, like if I go back up to this table, like we're adding 1, and then we're adding 3, and then we're adding 5. So that is where that second level common difference comes into play with the quadratic, because we're adding a little bit more every single time. All right, so we do not have a constant rate of change because we do not have a common difference there. We're not adding the same thing. Okay, and then the last one for this video, use a dashed line to draw the line of symmetry on the graph. So notice that about the quadratic, notice that about the parabola, is that it's mirrored on either side of each other. All right, so if I draw in the line of symmetry right here, let me see if I can make that a little bit bigger here. Maybe not. Here, I'll try to just accent that line of symmetry here that's going down this graph and cutting it in half. All right, notice that the left side is the exact same as the right side. We call that symmetrical. All right, so this line of symmetry here, line of symmetry is also called, you may also hear it called, the axis of symmetry. And in this graph, since it's a vertical line, I know it's been a while since we've talked about vertical lines and their equations. The equation of the axis of symmetry is x equals 0. Because notice, everywhere on that purple dashed line, that purple vertical line, the x value is 0. The y value is constantly changing. Okay? So notice that we had that symmetry. That's what I keep coming back to. So for B, give two x values that have the same output. So for example, I'm going to look at -3 and x equals 3. Because when I inputted those, I both got out 9. All right, what do you notice about the location of these x values in relation to the line of symmetry? All right, so notice up here, I'm gonna zoom in here. So notice here, like this is 3 units away to the left of your axis of symmetry, and then that's mirrored over here. It's 3 units to the right. So we have this idea of symmetry going on with a quadratic function, going on with the graph of it called a parabola, and that's really something important to notice. All right, so here, I'll just leave this note here. They are the same distance away from the axis of symmetry. Oh, that's bad. Let me rewrite that. All right, so we have those. We're just introducing some key aspects of the graph of a quadratic. In the next video that I cover, we'll actually go through some examples together, but go ahead and make sure you copy this down, write down any questions you have, all right, and then pay attention to the next video for some worked out examples. Thanks all.